So welcome everybody. Kind of happy to be here again at Black Hat to give a talk. And this time I'm here with Vincenzo, a colleague of mine. We actually work together on this research. And the title of our talk, as you can read there, is Cybercrime in the Deep Web. This is basically, we started working in this domain pretty much 3 years ago. So at the time I was down in Chile for a conference, and a friend of mine from Argentina, he showed me basically how you could use Tor, the Tor client, to get into Deep Web. And at the time I even didn't know what was Deep Web. And he showed me actually that you could buy assassination services and drugs. So I was pretty excited about that. So I said, okay, cool, why we don't develop a tool to basically crawl the Deep Web, to collect as much data as possible. So we started collecting the data, and it took a while because we collected pretty much more than 2 years of data. And here in this talk, we're going basically to present you the tool that we developed to automatically crawl the Deep Web and also analyze the content, okay? And so quickly about ourselves. So nowadays we both work for Trend Micro Research, and we both come from academia. Me personally, I was before I did my PhD in system security, and I work extensively with the guys that are behind Anubis and Web. So the system security lab it's called. And we pretty work on any different field of system security, from web to malware. Last year I was at Black Hat presenting a research on AS, which is like a tracking system for ships. So we are trying to basically position a Trend Micro not only as an AV vendor, but more like a 360 degrees vendor in security. So any topic related to system security is good to go. And I think Vincenzo can introduce himself. I don't have to do it. And they will basically take from here, do the first half of the talk, and I will follow up later on discussing a bit more in detail the type of malware which use the Deep Web and why.
Thank you, Marco. So unlike Marco, my background is more on the networking. I got a PhD. My PhD topic was basically peer-to-peer networks and how to make them talk to each other and so on. So it was a fairly good fit for this kind of research. After that, I joined Marco in Trend Micro. And we started working back-to-back on these kind of projects, amongst which also this Deep Web research. So I have a rather stronger development background, which made me ideal to develop the system, together with him. So the idea here was, again, when we got aware that there's a world out there of resources that are stealth and hard to track, which might be ideal for bad guys, we decided that we wanted something to both, make some research on top of it, and sort of gives our colleague, which are more into, more of an analyst profile, and they do investigations, do some tools to actually track malicious actors around the Deep Web as best as we can. So just to give the roadmap of the talk is going to be the following. I'm just going to give you a quick introduction of what we mean by Deep Web. I'm going to give you a quick detail of our Deep Web analyzer, so the system that we developed to sort of scrape the data and analyze it and organize it in a way that it's sort of easy to navigate. I'm going to give you some examples of what we found in terms of interesting resources related to illegal trading. So all sort of that crazy stuff that you read in the press from time to time, we'll see them here, what's in there. Some examples of the kind of data analysis that we can do and how can we exploit it to find, again, our interesting actors. And then Marco is going to focus on the malware part, so show you actually some malware that exploits the Deep Web and how we can track it actually, and then draw some conclusions. So first of all, I'd like to charm the crowd by being extremely pedantic, being told that works. Some definition first. So this is fairly important to make this distinction, because if you see the research, the early research that mentioned the term Deep Web at probably beginning of the year 2000, what they refer to as Deep Web was in fact content not indexed by search engines. And that's where you get, those papers that claims that the Deep Web is like the submerged part of an iceberg of which the surface web is just a tip and so on. Of course, it is. And they estimate that we have like 30 million terabytes of data hidden in the Deep Web and so on, which makes sense if you adhere strictly to that definition, which to this definition, which includes, your home banking page or anything that has a login page or anything that pretty much has a configure-robot.txt file so that the search engine doesn't index it. We have another definition that's the one that interests us more, which is darknet, which are actually private overlay networks dedicated to hosting resources like sites, images, and so on in a stealth way. And deriving from that, we have dark web, which is the actual World Wide Web hosted on top of darknets. So this distinction is important because, for example, you got things like, again, in the press, or you have quotes like this. So this is a documentary which came out this year from Alex Winter, which, curious enough, if you've seen Bill and Ted's Excellent Adventure, one was Keanu Reeves, the second one was Alex Winter. So it was that guy there, and he made this documentary about the whole Silk Road trial, documenting everything. And if you look at the trailer, you can actually do it right after the talk. It starts with this quote: "The deep web is vast, thousands of times larger than the surface web," said with a very deep and scary voice and scary music and so on. Which again, as I mentioned, yes, it might actually apply if you consider the deep web as, your home banking account. Then, of course, it's vast and there's a lot of resources there. But when you see, in fact, what's actually interesting for cyber criminals, the size might not be that big, and all the, the iceberg metaphor doesn't really apply there. So then you would say, but then why do you talk about your research about deep web research? I mean, you just said the distinction. That is why, actually, what we consider as interesting for malicious actors, in fact, is not just dark web, which include, Tor, I2P, Freenet, and so on. But we also try to sort of look up on other resources that might offer some interest to cyber criminals because they are, less regulated, like, rogue TLDs, they have a separate infrastructure, and so on. So I'll just go through this, very briefly to just give you an idea of what we are talking about. So Tor, raise your hands who never used Tor in his life, never heard about Tor. I figure one guy there, another guy. Okay, so we don't need to spend too much time on this. I think everyone knows it. It started as a way to allow people to go on the internet anonymously, overcome censorship and so on. Later in the development, they pretty much developed hidden services, which not only allowed people to actually go to, say, Google or, censor website and circumvent firewalls and so on. It actually allowed people to host websites in an anonymous way so that they are untraceable, by the customer, the users are untraceable and the servers are untraceable too. Onion routing, your request, jumps from hoops to hoop, encrypted multiple times, only, each hop on the path can only decrypt one layer at a time, so you never know exactly the complete path, in brief. I2P, the less known brother of Tor, I'd say. Unlike Tor, it doesn't technically allow you to go and browse anonymously surface web. It's dedicated to hosting hidden services, which are identified by those domain .I2P, basically. You can recognize an I2P hidden services because it has a .I2P top-level domain. For Tor, those would be the .onion domains, in case someone doesn't know. And it has a routing system slightly different, where in order to reach someone, you actually have a distributed hash table, someone like a NoSQL database that contains an inbound tunnel that you can contact to basically reach somebody, and that somebody can answer back through his outbound tunnel that gets routed to your inbound tunnel. All nice, guarantees anonymity, multiple level of encryption, and so on. Freenet, this is the kind of a weirdest of the three. So it's the oldest one of the three, in fact, is where I2P comes from. And it doesn't really allow you to host a proper website, where in I2P you can actually deploy an Apache stack and all, and actually host a proper website. Freenet, it's mostly for resource lookup. So you can post a resource on Freenet, like an image, a static HTML page, and so on. It gets identified by a hash key, and you can retrieve it, by using that hash key. So you issue a request to your network. You have a neighborhood, made of nodes you connect to. You issue a request for something. The request goes from node to node until it's found somewhere, and then you get your response back. So you can't really do dynamic web, but still, if you need to host, let's say, picture galleries or static files, that's just perfect. In terms of name coins and emer coins, so this is not really a stealth website hosting. It's mostly a way to register domains, like bypassing, ICANN regulations and so on. And they're basically, so these are systems that allow you to register domains using a blockchain-like technology. So imagine cryptocurrencies like Bitcoins and Litecoins and so on. So rather than storing in the blockchain actual currency transaction, like I give you 10 Bitcoins to that wallet, you actually register domain name information. So that guy had just registered this domain name .bit. That's the top level domain for Bitcoin. And so again, you actually need specific software to connect to it, but it allows you to actually host domains outside of the ICANN jurisdiction, for example. Same thing for RobTLDs. This is like the oldest of all the systems that's used to trick. It was fairly popular in the 90s where you had plenty of companies that would offer you your own top-level domains in their own DNS servers and so on, provided that you connect to their DNSs, basically. And some of them still survive today, actually, like Namespace, I think, is still doing something. OpenNIC. The Cecidian root, it's pretty much a whole weird world on its own. It's a system developed by a guy who invented his own country, religion, medicine, degrees, calendar, time things, and internet. He has deployed probably 20, 30 DNS servers all over the world that responds to that DNS. But that's another story. So again, with this in mind, we figured, let's see exactly what's out there. Let's collect some information, see how we can index it in a proper way so that it becomes usable, and see what we find. So we spent like 1 year or so developing our deep web analyzer, so this is the sort of the overview. It's made of several modules. So first one is, of course, data collection. So we try to pretty much find URLs everywhere we can, or as many places as we can. We index them in a way that allows them to be searched in very smart ways, and also to pull statistics, for example. And we see how these statistics can become very useful when you want to spot malware. On those URL, we go and do what we call scouting with this pretty much page crawling, finding basically everything about the URL. If it responds, the HTTP headers. If it doesn't respond, why? Do we have a problem with the resolution? Is it giving us an HTTP error or something? We get the page content, screenshot, parse the text. We do active port scan on some of the addresses to find things other than just HTTP, and so on. And we do that through our gateway. So we have basically a universal gateway that allows us to go everywhere in the deep web through just one port, combines all the different software there. With the information we got, we do some enrichment. Namely, we translate the pages, compute some word clouds, and so on. And then, of course, we can access the information, so either through some statistics software, such as Kibana 4. We store them in Elasticsearch, so Kibana 4 is the ideal companion, basically, to pull out nice graphs, trends, see exactly how much data we're collecting, and so on. And then we developed a custom portal, which allows us to actually do what we call the qualitative analytics, meaning actually go and look at the data we have. So what's the screenshot? What's the data there? What are the interesting links? And so on. So in terms of data sources, this is pretty much what we are trying to gather. We get user data, anonymized user data in particular. So from our users, we know basically what are the HTTP connections that they're doing. So we don't know who is doing the HTTP connection, but we can see the HTTP connection and see where is it going. So we basically parse them to find all the connections going to onion domains, I2P domains, .bit domains, and so on. We scrape sites like Pastebin, for example, and all the similar, Slacksy, Pasty, and so on, to find pastes with interesting addresses there. We have a Twitter feed. So right now it's the 1% feed, but we're working to increase it to the full data host, basically, and pretty much see exactly in tweets if we can find onions, I2P, .bit, maybe in the future recognize botnet traffics and so on. We monitor some subreddits, like our Tor, our onions, our darknet marketplaces, and so on. There are also some URL listing sites, like darknet links, I think, onionlinks.com, and so on. Just sites that post, list of links, and that you can get there. Tor gateways. So there are actually sites like tor2web.org or onion.cab which are dedicated to let you access resources on the Tor network without having to install the client. So the disadvantage there is, of course, that you're not anonymous anymore, because that website will see you actually connecting, and they will keep statistics actually of what are the most popular deep websites accessed through them. And those statistics are public, so we can pull them each day and basically see if there are new domains, new upcoming domains that are interesting. I2P host files. This is something similar to the server.met file that you have if some of you were using emules to do, piracy stuff or something, or absolutely not. So it's a file that basically contains some text, some information to help resolve I2P domains. Officially, an I2P domains is a big, long hash .b32.I2P. That's the actual address that is stored in the system. But you can actually register some readable domains, such as git.I2P, something that get resolved to their actual hashes. And in order to resolve them, you can actually download these text files that pretty much gives you this lookup information. And of course, by downloading these files, on a daily basis, we can see if new domains are actually registered. And then, of course, we got the feedback. So when we scout new pages, get all the links, feed them back in the systems to collect statistics, index them, and so on and so forth. So this is the Charon gateway that I mentioned. So it's our general deep web gateways. It allows us to just have a system point to just one port. Or if we have people doing investigations or something, they want to access deep web, just go to one port, we get deployed there, and what they can do is basically through Squid, depending on the URL they are accessing, it can redirect them to either Polypo and Tor. We got 64 instances running. We get an I2P instance there, if it's an I2P domain. We get Freenet running, if we have something resembling a Freenet URL. And then we have a custom DNS resolver that pretty much resolves, again, normal DNS, rogue TLDs, name coins, and everything. So connect to that port, get everything you need, makes things so much simpler. In terms of scouting, so as I mentioned, this is kind of all the data that we try to get. We use a headless browser that pretty much gives us back a full hard logs, meaning all the HTTP transactions that happen in the page. What we have is that a virtual browser window connects to the address, and all the other connections that come, either let be HTTP redirections or other connections, they're logged there. So we store them, and it can help us, for example, find drive-by downloads or whatnot. We get the full page DOM after every executing JavaScript and everything. So we get the final DOM. With that, we take screenshot of the page. We take the title, text, all the metadata, like all the keywords tag, meta tags, resources, all sorts of stuff. We store from some pages the raw HTML, because it can always come useful. Extract the links, as I mentioned. We try to parse email addresses and Bitcoin wallets. This is the kind of information. So this is what we are using, actually. It's a nice piece of code. It's called Splash from Scraping Hub, which, again, as I mentioned, it offers a nice headless browser that you can just deploy on your machine. It can either act as a proxy or respond to some REST request, so that you can just, you can either browse the web, using that as a proxy, and it will eventually store screenshots or store data from there, or you can use it as a server, connect to it, tell him, okay, go to this page through this proxy and get everything you can. To access that, we actually modified some Scrapy libraries and created some middlewares in order to access it, better, and actually integrated also with some shared queues so that we can launch multiple processes and make the thing more efficient and all. And as I mentioned, we extract all the links and everything. The other interesting part about this software is that you can also scripting through Lua and have it interact with pages, or that it supports no script ad blocks scripts. So, you can even use it for safe browsing, basically. So in terms of enrichment, as I mentioned, we collect the data. We do some enrichment operation on top of it, namely for all the links that we find, we go on our web reputation system, and we try to get the classification, for the surface web links at least, we get the classification and categorization. So is the link malicious? Is it safe? And if it's malicious, why is it malicious? Is it a disease vector? Is it a link to a proxy avoidance? for example, which doesn't really make it interesting, but we got it there. We do translation, so we try to normalize all the text to English, because it's what everybody speaks in the team, so we can get at that point, sort of at least get an idea of the page, even if it's in the furthest languages. We try to do language detection as well, of course, while we do the translation, which allows us to pull some statistics of what are the most popular languages there. And we do a significant word cloud, which means that we try to pull a word cloud out of the text, but in a more intelligent way, I'd say. So what we do basically, from the text, scraped from all the HTML, of course, we create our tokens, meaning word and occurrences. So word, how many times it happened in the page. We filter out and keep only the nouns. So, table, chair, stage, screen, and so just the nouns there. We get away all verbs and adjectives and so on. With the nouns, we compute what's called a semantic distance matrix, which means that we use a Python library called WordNet, which contains basically a graph of all the words in the English language connected to each other according to their meanings or to their taxonomy. So, for example, words like dog and cat will be fairly close into that graph because they're both animals. Baseball and basketball, fairly close because they're all sports. Dog and baseball, pretty far apart from one another. So using that graph, you can actually compute in terms of hopes how distant two words are from one another. And we use those, so we compute the distances for all the word pairs that we have. And we use that to do hierarchical clustering. So we create clusters of words with similar meanings, take the first of the words in alphabetical orders as a label, and then just use that information to compute an actual word cloud that tells us something more than just pretty much adjectives. So here's an example. I scouted a Russian forum. It's called Russian Silk Road. Looks interesting. I have no freaking idea what's telling it here because unfortunately I don't speak Russian. But if I go check on the word cloud, at least from the top 20 words, it looks like it's, again, registration rules, forum, trading, razors, Silk Road, of course, register, and so on. So at least it gives us a glance right away of what's a page can it be about and if it's worth looking further into or not. So this is more or less, yes, it's an estimate of the collected data that we got. For in 2 years, we pretty much had like 40.5 million events, which means each event is when we find a URL, basically. So we spot a URL, it's one event. We spot it again, it's a second event. In total, the URLs that we collected are like around 610,000 URLs. For a grand total of more or less 20,000 domains or 20,500 domains. Keep in mind, though, that in terms of volatility, it's very volatile data. You got something like Operation Anonymous, and in one day, all your data becomes crap because there's a massive takedown and most of the sites go down. And so all the data you collected works as historic data, but the sites are not there anymore. So again, I think right now of all the 20,000 domains, we're probably around 9,000 actually online, last time I checked. So I'm going to show you a couple of videos that give you an idea of how our portal works. You will forgive me if I don't do the connection, but it's like a double tunnel connection, and I really don't trust wireless networks around conferences. So this is an example of a URL summary page that we have in the system. So with the statistics I just showed you, here is a breakdown basically where all our URLs are grouped by host name with path. Clicking on the plus star, you'll see we can get path, and clicking more, we can get query strings. In green, you can see sites that contain pages that we managed to scout. So sites with pages that responded to our crawler. In yellow are actually pages that we tried to crawl, but either didn't answer, didn't resolve the name, or we got an HTTP error. And those pages are not to discard because they can be interesting too, actually. So these are the pages. While in red, we actually find pages that we scouted and contained links that we rated malicious. So these are pages that contain links which we rated malicious, and they should be interested on their own part. So we can actually do search and filters. So for example, here I'm filtering and just find the I2P related pages. Here you got an example of those long hashes with .b32. I can filter and just find the malicious pages, and what I find here, for example, is the scan4u.i2p, which happens to be a counter AV service, something like VirusTotal with bad guys, where you basically pay to submit your piece of malware and get the malware checked against all AV engines, much like VirusTotal, but without divulging the information. So if you're developing some new malware, you could actually, get it checked there, and have the information kept private. So again, the word cloud here sort of gives you the idea: antivirus checklist, virus, and so on. We get the page screenshot right there. Under here, the word cluster. So the word cloud is made of the top 20 words. In the table below, you actually see all the words that got picked. So again, see the kind of clusters that you get: list, database, blacklist, spyware software, guard, defender, and so on. After that, we got the links. So yeah, as soon as I move back, we got the links there that were present in the page. This is the links that made the page, that marked the page red, is the execrypt.com, which happened to be, again, it was rated as internet security disease vector and marked as dangerous. That is because that's actually a site selling cryptors, so software that allows you to obfuscate your binary. Either thing, yeah, we got the tags, resources, and so on, basically. Another demo, this comes from the scouting page, which is the page where we can do either searches on the page content, or we can do searches on, for example, the URLs, as we will see. And this shows you, and actually look at the data itself without caring exactly how the URLs are organized. So in this case, we are, we show you actually how to do a search on the URLs to find, for example, open directories. So there's a particular kind of open directories, particularly the one generated by wget, which presents a URL with two query parameters: a C, which means sorting criteria, and a O, which is the sorting ordering. So in our case, we actually store and index the URLs by all the different components, which allows us to go and search for those specific query parameters and retrieve pretty much everything in our database that it's pretty much an open directory, which is fairly interesting, because then you can go and find, if there are drop zones, if there are leaks, or all sorts. So here's, for example, we open one. The screenshot shows that it's a file list, as we expected. The word cloud here doesn't mean much, being a word cloud made of file names, which would be mostly gibberish, and so on. So back to the presentation. So let's see some examples exactly of what we found there. Pages and interesting things that we got to spot. So one of the most interesting guns, of course. This is a store claiming to be in the UK. You can basically find stores everywhere, pretty much in every part of the world. Again, I honestly have no idea how, 1.4 Bitcoins for a Glock 99 seems fairly convenient to me, mostly because, it's unregistered. So, and again, you wouldn't go there to buy guns because of the cheap price. You would go there because you pretty much need no license or anything. In terms of drugs, I don't even need to actually say it. This is, what everybody sees in the press and so on. From marijuana to all sorts of drugs. You can see here crystal meth, coke, and everything. This is the main driver of the economy in the deep web, no doubt about it. Passport and fake IDs. So this site claims that it will provide you with the Dutch passport for 600 euros, which is fairly interesting. They got pretty much many interesting nationalities. The US one is the most expensive. You can actually get it with driving license and ID card as well. They even take care of duplicates in case you are so clumsy to lose your fake passport. Counterfeit money. Again, here's an example with euro bills, 25 by 50. For Bitcoins, you can basically get a fair amount of 50 euro banknotes, or at least that's what they claim. Because we can check the claiming of the website. Then, in order to go actually and check if the website is legitimate and so on, you need to either do an investigation or a cover operation. But I can't really go and try to buy stuff to see if it works, because that's called financing criminal activities in most countries. So. So this is, take it as they are. They claim to be. They look like a respectable, shady business, whatever that might mean. So, but I haven't checked personally. Credit cards, again, you can buy them in bunch, with maximum balance. Of course, being either stolen or cloned, they might not work, so you get maximum balances, and withdrawal limits, the higher they are, the more you pay for them. This is very interesting for social engineers. You can actually buy packs of PayPal accounts. So 100 PayPal accounts, of which 80% is given as working, which again, fairly interesting there, for 0.3 Bitcoins. If you have to do, again, scams and everything, this is what you want to look for. What else? Doxing, some fairly interesting pages, sort of giving out personal information about high-profile figures. In this case, there's an example with Bill and Hillary Clinton. This is the actual picture of the address depicted there that we leave it there. The 1600 Pennsylvania Avenue, we figured it wasn't really worth censoring as it's the address of the White House. So, it's not really that secret, I'd say. Assassins pages, again, self-declared assassins. People will claim that for the convenient price of 7,500 euros, they might kill someone aged 20 plus in the 3 continents and so on. Haven't checked, so far. They claim that rumor says that mostly would be scams, no way of verifying it, but again, if you had the chance of putting on a website that isn't traceable and your identity will be covered and you have the chance of getting payments with the currency that isn't traceable itself, and let's say you want to target people who might not go to the police complaining about their 7,000 euros being stolen by a supposed hitman, well, you see how this is a really good plan to get money from fools. On the topic of getting money from fools, meet your new Kickstarter, Crowdfunding Evil. This is pretty much, it was a website called Deadpool. What they would do is that they would have a list of high profiles. Again, Barack Hussein Obama, Justin Bieber, just because it's as a high profile. Hugh Grant, not the actor, the other one. Apparently the actor is pretty much beloved by most. So they would put a bounty on them, say $2 million, I think it was, for Obama, and says, okay, let's start doing a Kickstarter campaign here. So you give us the money. When we reach $2 million, we promise you we're going to hire an assassin and get it done. Sure. Again, I still see Obama around, so looks like they didn't reach the $2 million. Of course, everything goes in Bitcoins, clearly. So moving on to some other stuff on the data analysis topic. This is a breakdown of the URLs we collected in terms of what kind of view of protocols we find in the URLs. So either than HTTP and HTTPS being pretty much 90% of what we got. What's interesting, we see plenty of IRC servers, some IRCS, XMPP, which is XMPP being the Jabber protocol, which is fairly interesting because this could actually be used either as a rendezvous point for malicious actors or as an infrastructure for botnets and CNCs and so on. If we try to do an active port scan only on Tor hosts, and this is the actual numbers that we find lately. So pretty much 49 IRC, 31 ARCS, and 800 SSH, which is fairly interesting on its own. This is an example of the IRC servers that we could find, some Cyber Guerrilla Anonymous with the channel dedicated to solidarity with jailed Anonymous people, well, members of Anonymous, basically. In terms of languages, of course, normally now English is the most renowned language we could find there, Russian being a strong second. If we take them off, we actually see French and German following up, some Italian, Portuguese, and Dutch being around here, pretty much in par with Finnish and Japanese. Not that many, I gotta say. Just out of interest, this is done counted the number of domains that show that language, so it's not in terms of number of pages. This is an example of what we find, for example, in the French sites. There's a guy in a forum trying to sell some weapons again. I think Nouveau Arme. Yeah, it's a Colt 45 from 1911, apparently. So it's not even that shady, I'd say. In terms of pages embedding suspicious links, so this is what we can find when we look at the pages again, with links rated malicious. As an example, here you got an offering for a guy trying to sell, some Predator Paint and Autologger, so some some malware basically out there, and keyloggers in particular. In the term of email identifications, as I mentioned, we parse emails there, and we can run some nice statistics on top of it to find, what are the addresses that are used out there and so on. And here, interesting is not really too interesting. The top one, like ZZZ, is like one of the main developers of I2P, so it's really not that shady. You got some QQ addresses here, and there is something like Toxic Poison or a Bank from America one, which I gotta say, this is not actual Bank from America, it's just a guy using a username. You had no idea how Bank of America can get pissed if you nominate them there. So if we actually check and see what are the associates, so what are the other email addresses that we find in the pages containing the Bank of America at mail to Tor, again, not the bank, just a user using the name. We can find other interesting addresses here, such as nullcode, for example. And I can go dig in the pages and find a post in the Exilio forum when said nullcode was selling some credit cards and some approved credit cards here, and to which, later on, Mr. Bank of America, not the bank, was responding. Again, with this email appearing right here, and his Tor chat address in there in case anyone is interested. In terms of Bitcoin, we also try to scrape everything that looks like Bitcoin addresses. We found what are 1,200 more or less Bitcoin wallets, or at least candidates. Again, we run regexes on there to find the candidates, and we try to be as precise as possible. Unfortunately, as Marco will show you, there are ways on certain pages to obfuscate Bitcoin addresses so that while you see them in the page, in the source of the page, they're in fact scrambled around. In terms of services, we got some money laundering service for Bitcoins. Again, Tumblr, basically, you send them money, they keep a fee, they sort of rumble them around, make some fake transactions, maybe just jump to another currency and go from Bitcoin to Litecoin and then back so that your money becomes hard to trace, basically. On the other side, there are Bitcoin multipliers that claim, and again, you send them 1 Bitcoin, they give back 100. For reasons, again, that's what they claim. This one in particular, I really wanted to, at least to show its legitimacy, and it's actually showing you, the successful transactions that you can trace on the blockchain to see that in fact the Bitcoin got multiplied and they got a list of happy customers. Let's move now to malware, and I let Marco continue from here.
Okay, thanks. Hello? Okay, good. Cool. Thanks, Vincenzo. So in the rest of the talk, we are focusing on malware. And the cool thing is that, back in the 90s, when malware was mostly spread via, like floppy disk, and was just a piece of code running on your computer, finished. Nowadays, it's heavily network dependent. So without network, malware basically is dead. And it's, for example, infection time, a bunch of malware now propagated using drive-by download, so via web. So basically they need the web, to infect the machine, as much as in propagation time when they move from one machine to another, or when the author of a malware want to update his code, or when you have a dropper which download a second stage malware, you need an infrastructure, so the network to deliver the new second stage malware, for example. And also when it comes to command and control server, so infrastructure used to run basically the whole infrastructure for a botnet, you need a network. So you need a server hosting the command and control. And so why malware authors are interested in the deep web? Mainly because they want to make their malware infrastructure, such as botnet, very resilient against law enforcement attacks, operation, for example, takedown or sinkholing. And this is perfect, because in the deep web it's very difficult to do sinkholing because there is no concept of IP address, very difficult to locate a server, the same for takedown. And then another goal is to conceal the payment page. As we'll see later in the talk, there are a class of malware, which is the ransomware, for example, that at certain point they need to cache out. So the possibility to hide those pages in the deep web is very interesting. So Brown, 5 years ago at DEF CON 18, or 4 years ago, discussed theoretically about the possibility to use the deep web for malware authors but there was no proof. Okay, so here is what we're going to show today is actually some example of malware family which extensively use the deep web for different reasons. So the first one is Skynet, which is a malware with distributed enough service capabilities, Bitcoin mining and banking capabilities, and has been discovered by Claudio when he was working in Rapid7, together with some guys from GData. And so the idea is that basically the malware come with a deep web client, which allow the malware to log into the deep web, particularly into Tor. And so what you can see here is that the malware itself uses this PHP script as a landing page to store the credentials that are based on the affected machine. So what you can see here, down here, is that using our system, we can query for this path, and easily we can see that the first two domains reported here are the two command and control servers used by this Skynet malware, with a number of connection going to the command and control server. We can also plot over time the evolution of the command and control server. So we can see that back in May, there was just one command and control server being used by this particular malware. And later on in September, the author introduced a second command and control server operating concurrently to the first one, which is in light green, and then Shadeout and other command and control server were introduced in late October. Similar to this is the Dire banking Trojan. So this is a BHO that basically do man in the middle of online banking pages. And basically it works by, when you get compromised, by hijacking the session at client side. And what's happened is that when the user basically log into his the online banking, the code, the session which has been hijacked, connect back to the attacker in kind of the reverse shell approach. And in this way, the attacker has direct access to the online banking account of a user. And this particular code, it used DGA, which is domain generation algorithm at IP level to basically generate different type of domain, hide behind fast flags network to host the infrastructure on the IP. But this is not enough, because nowadays, a bunch of companies and vendors, they have way different systems to detect fast flags and DGA algorithm. So what they do, they also use the I2P. So it's the only malware out there that uses I2P to host the command and control infrastructure. And so last year, in 17th of December, there was just this single domain being reported through VirusTotal as using I2P. So here we disclose a couple of other domains used by the Trojan, and we can see an infection over time. So nowadays, the malware is actually still functional, and actually there was a peak over the last couple of months. So we show actually that malware authors are more and more, using the deep web as, form of setting up their infrastructure. Another banking Trojan, which is pretty interesting to mention, is Votrack. So I don't know if you attend the talk before on steganography. So what this malware does, it basically hide the IP address of a command and control server in the icon file. Okay, so the icon file, if you download the icon file, it appears just as an icon. So, but the IP address are steganography hidden in the icon file. On top of that, the web server hosting the icon file are hosted on the Tor network, which means that the malware author here used the combination of steganography and the use of Tor network to make their command control server more resilient to possible takedown. And so how we can detect such stuff? So what we did, we basically, by analyzing the code, we found out that basically the malware author was using as a web server a specific version of OpenResty. So basically this condition, together with the condition that the path contain, of course, this 5gon.ico in, as a file name, and the fact that when you basically do a get to this address, instead of having a 200, which is a normal return code for HTTP, you get a 403, which means forbidden. So these three conditions together, we can add them to our system, and the system automatically tell us wherever there are some URLs that has the three condition matching. Okay. And so if I query for that, I got a list of 23 command and control server related to this piece of code, which are plotted here. This goes back to February. So we start seeing the infection in February, and more command and control server have been introduced in the network. As you can see that actually the trend is going up. So it's not myself painting this image, but it's actually the system which gives it to me. And so what we want to talk now? We want to talk about the ransomware. So ransomware is been something that we are tracking a lot because it's an emerging threat and affects a lot of people all around the globe. And it's interesting to see that in addition to the possibility of using or misusing the deep web to host command and control server, the ransomware is really interesting of using the deep web because the deep web itself, or its characteristics, provide a hidden and robust framework to cash out and for illicit money transfer. What does it mean? It means that basically, if you all know how the ransomware works, if not, briefly what happened is that, without going into detail, so basically your computer gets locked or the file that you use get encrypted and you get asked for a ransom to pay in order to get your file back or your computer back, okay? And usually what happens is that, okay, you pay and then the file is given back to you. And the interesting thing is that when you want to track some cyber criminal, basically in the chain, the weakest point is the human. So at the time when they turn basically the technology into real money, is the time when you basically can get to know who is behind, so you can basically do attribution. And so the cashing out is usually the critical part for the bad guys, because it's where usually, as I said, you can basically identify them. So one of their goals is to hide all the framework for cashing out as much as possible. So what they do here, they basically host the payment page on the deep web, such as very difficult to track basically the server which is hosting the page. And so when your computer gets infected, basically you have to click on a link, and the link points you to this page that says, buy, in this case, I can barely see myself, so let me see here. It's 1,200 Australian dollars. You have to buy Bitcoin for more than $1,000 US, and you have to pay through the wallet, which is down here. So basically the page itself is hosted on the deep web. The payment is done through Bitcoin, which makes it even more difficult. And the other interesting things that sometimes what the criminal does too, they ask for a payment in Bitcoin, and then they go from Bitcoin to Litecoin, or from Litecoin to another currency. So it's very difficult when they basically transfer from one currency to the other to track them. So the fact that they use a combination of different cyber cryptocurrencies make very difficult to be tracked. Another interesting thing that goes back to what Vincenzo was saying before is that the address here is shown as a Bitcoin address, but in the code of the page is actually shuffled, is obfuscated. So it's very difficult, to crawl this page automatically. Actually, we are not able of doing it. This one, we found actually for the system I'm going to describe later on, but we didn't found actually the page by searching the Bitcoin address because it's not a regex. You cannot do it with regular expression. So what happened is that when a machine gets infected, the malware generates a user code and user pass, kind of one-time user code and user pass. And it does it to log the infected machine into the payment page, which means that, again, you, as if you are a law enforcement agency, or if you want to crawl the deep web, if you don't have this token, you cannot access the payment page. So that's one technique he used to block the payment page to non-infected machine, which is pretty interesting. Second thing he does to provide the page with a language specific to the guy that's been infected. So if you are like in Netherlands, your page will be in Dutch. If you are in China, it will be like this one. So what we can do here in our system, we can type this kind of regex into the system, and we can search for all the payment page. And we can have an estimation on the number of infected users and where they come from. As you can see here, we have basically users from different countries, and most of the infection are for native US-speaking or British, followed by Turkish, French, Chinese, and Italian. This is done because in automatic, because we have a module, as Vincenzo mentioned, for language detection. So we do the detection of a payment page, like this one, okay? And yeah, let me conclude with this example without taking too long here, so we can have some time for questions. So the last one is Nine Spy. This is a piece of code that does pretty much everything. So it's still confidential information such as keystroke, password, private documents, and there's a bunch of functionality that are very interesting for people that does kind of espionage, for example, target attacks, and so on and so forth, because the code allows to record video and audio. And so the idea here is that what we look at wherever there are a kind of emerging trend, kind of surging popularity in the number of values associated to the same query string parameters. So that's the idea. So the idea is that suppose you have you are infected, right? Or there is a new infection. So what happens with new infection? Usually, when a machine gets infected, what it does, it communicates to the command and control server about the new infection. Okay, and it does if it does using a GET. Basically, what happens is that in the query string parameter, as you can see, let me go directly here, which is easier. So in the query string parameter, for example, this parameter come with a blob, with the JSON blob which is reporting infection. So if there are a bunch of infection in a very short amount of time, you see basically a spike like this one. So you have a spike of one parameter with a bunch of different values. And so what do we have? Basically we can, using our system, automatically we have a nuller wherever there are these cases, okay? And if you go in detail here, what I can tell you is that this parameter called XU experienced a quick surge in popularity over the last couple of weeks, over more than 70,000 different values associated with the same parameter. So we said, okay, wow, what's going on here? So we look at parameter and we saw that the value itself was kind of weird because it was in a URL encoded binary blob. And at the end, it turned out that this was basically the data that are leaked from the affected machine. So the malware used a GET to communicate the data instead of a post, so we can see directly on the URL string. So you communicate that. You communicate also a new infection together with the operating system of the machine, the language, and all the different information. And we can plot it here. So we can plot the traffic over the two parameters. And we can see that in the, here with the blue, yeah, here it's blue. So the number of new infections is going down, while it was pretty, more. We had one day in middle of, May? Yeah, middle of May with over 100 new victims on a single day. And the same with the traffic. So that's some of the analysis we can do with our system, and it's something that actually we are doing it. So basically, the take home here for today is that, together, me and Vincenzo, Bailey and Vincenzo, that did the whole development. We built this system for doing the collection and the analysis of the deep web, which is something unique that has not been done before, and we're actually using it. We're using it to detect different types of cybercriminal activities, such as trading of illicit goods, as Vincenzo showed. We are tracing underground forums and marketplaces to understand what's going on. We want to do in the future some automated analysis and correlation of different emails, of a different blog post to understand which author are talking to whom, from which blog post. We want to correlate the deep web with the surface web to try to de-anonymize users in the deep web. That's something we want to look at. We are focusing on malware, try to trace new campaign, malware infection. And so that's pretty much what we have done. And I think we have a couple of minutes for questions here. So don't be shy. And it's your turn now to contribute to the talk. Thanks a lot for listening. I hope you enjoyed what we had today for you.